let's see one gate question. Gold and silver ornaments are precious. And given that g of x means x is a gold ornament, s of x is silver ornament, p of x means x is precious. Given these functions are predicates, so what is the correct interpretation of gold and silver ornaments are precious? That's the question. So if you read the question clearly, we are talking about ornaments, isn't it? Let's take domain as ornaments. Now, are we talking about all the ornaments? No. We are talking about few ornaments which are made of gold or silver. I'm trying to understand the meaning of this statement. That's what I'm doing. Okay. So here, this statement claims that if the ornament is gold or silver, though it is written as and, but still the meaning is, logic wise it is or, isn't it? So if the ornament is gold or the ornament is silver, still it is precious. So that's why I want to say that for every ornament he is talking about. So for every ornament, if it is gold ornament or silver ornament, whatever it is, so they have some property. What is that? That property is being precious. That's it. So finally the answer will become option D, not option B. The problem with option B is just we know how to read given a first order logic statement, isn't it? Let's try to read it. For all x, every ornament, whenever that ornament is made of gold and silver, then it is precious. That's what the meaning of this one. It's wrong. Again, I'm reading it. For every ornament, if it is gold and silver, then we are claiming that it is precious. We don't want to claim about, ornaments which are made of both gold and silver. We want to claim about ornaments which are either gold or silver. That's why here R comes. Then why and is given? In the gate question, they want to confuse you and they want to check whether you understand the logic behind anything or not, rather than directly do you use and this and do you match like this is a thing they check. So that's why you should be very clear. You should understand something very clearly, right? So if you understand this statement very clearly, you can answer it. What's the big deal? Okay. But the students who do, literal translation like and versus logical and, whoever does it, they will definitely lose this question. Let's see this problem. Every teacher is liked by some student. So how to answer this one? If every teacher has a property, then how you write it? If every line has a property called drinking coffee, how you have written? You have written like this. For all x, lion of x implies coffee of x. In the place of lion, now you have teacher. Then how you write it? For all x, teacher of x implies something of x. So that's why your correct answer should have for all x followed by teacher of x implies. So teacher of x implies. So option A may be correct. For all x, teacher of x implies. For all x, teacher of x implies. And for all x, teacher of x and. This is wrong. Now we have A, B, C. Out of them we have to eliminate the remaining two options. So how to do that? If you observe, there exists y, there exists y, there exists y. That there exists y is going with student and likes, student and likes, student and likes. But there is implication in one place, there is and in one place. We should decide whether it is and or implication. Okay. Now only focus on this area. Okay. It is about claiming there is some student who likes X, right? How you write this kind of statement? There is some student who likes X. How you write it? Then it is like there is some cat who is intelligent. Both are same. Try to understand. There is some student who likes X. That means who has a property is exactly equal to there is some cat who likes, who is intelligent, isn't it? So whenever there is some cat who likes intelligent, how you have written? There exists X, cat of X and intelligence of X. Correct? In the same way, this will become here, it will become there is some Y who is student and property of X. So that's why the correct answer structure should be there exists Y, student of Y and property of something, like it's a remaining property. Correct? Some student has a property. So and comes, right? Already we know that. Then any option has implication, please avoid it. So option A is eliminated. Now we have option B, option C. Now what is the difference between these two? Everything same, but you have there exists Y after for all x. Here you have there exists Y, before for all x. Then which one is correct? Let's take one thing. Let's take option C and interpret it. Okay, we'll interpret it. How to interpret a formula? I explained you, correct? So in the place of there exists y, first of all fix a particular candidate Raju and think about it. So what happens? So here it will become Raju and here it will become Raju, isn't it? Now try to read it. For every x, whenever x is a teacher, then this is happening to the teacher. What is happening? So Raju is student and he is liking x. So whenever x is a teacher, let's avoid this part. Whenever x is a teacher, for the teacher this thing is happening, this property is happening. What is that property? So this property is nothing but there is some y, already we fixed, sorry, we fixed Raju, right? There is someone like Raju. Raju is a student and liking that teacher. Finally, whenever this formula is correct, every teacher is liked by our student Raju, isn't it? That's what the statement. But it's not Raju actually, correct? It was someone, okay? Maybe Rani. If I fix in the place of Rani, then what could be the meaning of this statement? Every teacher is liked by some student Rani, correct? In the place of Rani, if I keep Rakesh, try to understand. In the place of Rani I am keeping Rakesh, then it will be again for every x, whenever x is a teacher, then student Rakesh is liking that x. That means every teacher is liked by student Rakesh. Now let's generalize it. It's neither Raju nor Rakesh nor Rani, isn't it? Then what is it? Someone. Whoever you substitute, that someone is going to like every teacher, isn't it? After substituting y, that y is liking every teacher. Then I can read this like someone is liking every teacher, isn't it? Someone is liking every teacher. But our statement is different. We should have every teacher is liked by some student. Okay, every teacher is liked by some student is different from some student is liking every teacher. There is a difference. Try to understand. Okay, so that's why option C is wrong here. Especially some student is liking every teacher, but that's not compulsory for me. In my statement, every teacher should be liked by some student. That some student may not be same. Maybe teacher 1 may be liked by Raju, teacher 2 may be liked by Rani, teacher 3 may be liked by Rakesh. Still I say every teacher is liked by some student, isn't it? For that, it is not compulsory that some student should like every teacher. You understand that? Okay, so that's why the correct answer is option B, not option C. Now if you have doubt on option B, just read it. So for every x, for every person, whenever that person is teacher, this is happening. Whatever the teacher you take, this is happening. What is happening? Immediately there will be some student. You can show some student so that that student is liking that teacher. Okay. Now this someone is not every time same one. For every teacher I am showing someone. It doesn't mean that I am showing the same one. Correct. So because of that, this is absolutely says that every teacher has some student to like. Correct. That's why every teacher is liked by some student is absolutely this one. So in that way, any gate question we can answer. Let's see one more problem which is asked in 2004. Some boys in the class are taller than all the girls. Is it not like some cats are intelligent? Some cats are intelligent. Then there exists x, cat of x and intelligent of x. In the same way, some boys are having a property called taller than all the girls. Then there exists x, boy of x and the remaining property. Boy of x and property of x. So now other options, like boy of x implies property of x is wrong. Here boy of x implies property of x is wrong. Now only options B, D. Now in these two, the difference is you have and here you have implication. Which one is correct? If you see this one, so we are saying that there is some boy, that boy has a property. What is that property? That property is that boy is taller than all the girls, isn't it? Like these are all, let's say, girls, then girl. So this boy is taller than all the girls. This property we should represent. Okay, in the different way, in a opposite way, can I say that every girl is shorter than this boy? Let's say this boy is x, so I want to say that every girl is shorter than this boy. So That's what, because why I'm thinking in this way, the reason the formulas are given in that way. That's why. So I take here every y, that means every person. If that person is girl, then definitely that girl is shorter than your fixed boy x, correct? So remaining thing we should fill, correct? So that's why what I want to say is, if every girl has a property, then again it's like every lion drinks coffee. How you write? For all x, lion of x implies drinks of x, coffee of x. In the same way, if every girl has a property that that girl is shorter than boy, then again implication comes, for all y, girl of y implies remaining thing. That's why automatically implication comes. So by having high level understanding, we can say directly option D is the right answer, isn't it? Now, why this is correct, we'll see clearly. There exists some x, he is boy and he has a property. That is first level. Now understand this one. Whatever the y you take, whenever y is a girl, then what is happening to that girl? That girl is shorter than, because x is taller than y, that means y is shorter than x. So for every y, whenever y is a girl, that y is shorter than boy x. Why? How can you say that x is boy? Already because of this formula. Already this is true. If this is true, x is boy. That means there is some person in the world who is boy, and that boy, whenever I substitute here, so every girl is shorter than that boy. Finally, I can say that there is some person in the world who is boy and he is taller than every girl. That's why option D is the right choice. So by understanding in only 50%, still you can answer it. For all goes with implication, there exist goes with and. If you know this thing, is you can answer it, right, by elimination method. Let's see one more question which is asked in GATE 2010. F of x comma y comma t is nothing but person x can fool person y at time t. So they have given a formula, for all x there exists y there exists t, and not of f of x comma y comma t. We have to understand it. There are four options, we have to match it. What I do is, it is very difficult for me to understand it, isn't it? So that's why I take first f of x comma y comma t and I understand it. F of x comma y comma t is nothing but x can fool y at time t. Not of f of x comma y comma t is nothing but x cannot fool. That means x can fool y at time t is wrong. That means x cannot do it. That means x cannot fool y at time t. It is given that there exists y, there exists t. I am extending this formula to this one. There exists y, there exists t, not of f of x comma y comma t. Now y become variable, t become variable. X is still a particular person. Let me take it as Raju. Now if you read this one, before there exists y, there exists t, it was Raju cannot fool y at time t. It's not about a particular y, particular time. Some y, some t. Now read it with some y, some t. Raju cannot fool some y at some t. Raju cannot fool some person at some time. Isn't it? Read it. Now extend it to for all x. It's not about Raju. Everyone has same problem. They cannot fool some person at some time. You remember that point. That's the summary is no one. Okay, everyone has some problem. What is that? They cannot fool some person at some time. So I take this particular person Raju and I show the structure. What's the problem with Raju? Raju has three friends, Rani, Lakshmi, Rakesh, but Raju cannot fool some person among them at some point of time. Let's say, assume that that person is Rani. Okay, so let's say that Rani cannot be fooled at time 9 o'clock, correct? Still Rani, Raju can fool Rani at other times, but definitely there are times where Raju cannot fool Rani. So that's why I assume that Raju cannot fool Rani at 9 o'clock. Remember it. And what about 10 o'clock? I don't know. 11 o'clock? I don't know. But definitely I know that Raju cannot fool Rani at 9 o'clock. That's why Raju cannot fool some person at some time. What about Lakshmi? Raju, can fool Lakshmi at any time and we don't know any information. So that remaining things we don't know. So Raju can fool Rakesh or not? I don't know. At 9 o'clock, 10 o'clock, no information available. Okay. So still we have options, I'm saying. With that, go to the options now. See the option number 1. Everyone can fool some person at some time. It's not about fooling. How can you say that everyone can fool some person at some time? I don't have that information. I have information that everyone cannot fool some person at some time. Correct? So that's why option A is wrong. Now see this time, option B. Let me postpone option B. I will tell you because it's a correct answer. Now directly go to option C. I will tell you why option C is wrong. So option C is everyone cannot fool some person all the time. Understand it? Everyone cannot fool some person all the time. That means this statement says that everyone cannot fool some person all the time. Why? See, if really everyone cannot fool some person all the time, then Raju also should not be. Raju also should do the same thing. That means Raju cannot fool some person all the time. Is it true? Raju can, fool Lakshmi all the time. Just assumption, because we have option for Lakshmi, right? So Raju can, let's say, if fools Lakshmi every time, 9 o'clock, 10 o'clock, every time, then still Raju cannot fool some person at some point of time. I am not violating it. Now, this option will become wrong. What this option says? Everyone cannot fool some person all the time. But Raju can fool Lakshmi all the time. Right? It's possible. That's why option C is wrong. Okay. So, but still Raju cannot fool Rani at some point of time. Without changing that, by assuming something about other points like Lakshmi and Rakesh, I made option C wrong. See the option D. No person can fool some person at some time. So this statement says that no one can fool some person at some point of time. Why? I'll show. Mr. Raju may fool Lakshmi at 9 o'clock, let's say. Then this statement is wrong. It's possible, right? If Raju fools Lakshmi at 9 o'clock, then saying that no person can fool some person at some point of time is absolutely wrong, because Raju did it here for Lakshmi. Understand that? So that means option A, option C, option D are wrong for this example, but still, so only option B we have to mark it. Correct? So why option B is correct, I will tell you. What was the problem with Raju? Raju cannot fool some person at some point of time. Who is opposite to Raju? Let's say if some person exists who is opposite to Raju, how he looks like, what is his behavior? Raju's behavior is Raju cannot fool some person at some point of time. Then opposite behavior is a person who can fool everyone at every time, isn't it? Understand? So what's the problem with Raju? He tried to fool some person at some point of time, so he was not successful. Then who is opposite of that? What is the opposite's behavior? Then if some opposite person exists, then he can fool everyone at every time. Raju cannot do that. That means Raju cannot fool everyone at all time, right? So not only Raju, this formula for every X. That means every person in the world will have this problem. They cannot fool everyone at all the time. So no one can fool everyone all the time. That's why option B is the right answer.